So now we arrived at this point, and then we say since f, which is the f that we're referring is this value, which is 12.7328, which is greater than what? 4.75. So what does it mean? We are going to reject H naught. We're rejecting H naught based on this rejection criteria. So when you reject H naught, we're going to conclude that the regression model is what? Is significant. Remember, I have explained to you that if beta 1 is not equal to 0, we're saying that the regression model is what? Is significant. Because if it's 0, it's insignificant, the regression line. Because let's go to the model that we came up with. If this is 0, which means xi goes, so remain with what? With the constant, which is not a regression, which is not a regression model, right? Next question. Test the significance of the regression constant. Or sometimes they may say test the significance of what? Of the intercept. Using alpha is equals what? 0.01. So now here we are testing for what? For beta is equals what? To 0. So you're saying H naught, beta naught is equals to 0. H1, beta naught is not equal to what? To 0. I think when we introduced this chapter, we talked about this, right? We talked about this. Let me go back to the notes where we discussed about this. Yeah, this is the area where we started discussing about this concept. Yes, this is, yeah. After it derived the standard errors. So this is for beta 1, this is for beta naught. So if you're testing for beta naught, right, you're going to use this. So this formula follows a t distribution. I'm sure this is what you're covering in inference, those who are doing inference. So this is t is equals to beta naught h minus beta naught square root of s squared bracket 1 over n plus x bar squared over sxx. So this beta naught h, be careful on how you write this. This is an estimated, this is a true parameter. So now we can go back to so this is our formula. We are saying it's beta naught h minus beta naught divided by the standard error of beta naught. But the standard error of beta naught here is supposed to be a square root under this formula. And if you're going to follow this, so I'm saying t is equals to beta naught h minus beta naught divided by the standard error of what? Of beta naught, which follows what? A t distribution with n minus what? 2 degrees of freedom. So what's the rejection criteria? We reject h naught. It should be, I'm sure I should be corrected. It should be the absolute value of t. So you have to correct that. It should be absolute value of what? Of t is greater than what? T alpha of what? Over 2. So this is a two-tailed test. So the distribution allows us to consider what? A two-tailed test. That's why you're dividing alpha by what? By 2. And then which is n minus what? N minus 2. So we need to get this critical value from the tables using the t distribution. So if you're going to use the alpha that you've been given, it was 0.01 divided by 2, you get 0.05. Then out of our n, it was 14 minus 2, we get what? 12. Right? Then this is a critical value that you get from what? From the tables. So this is our t, which is equal to what? Beta naught divided by the standard error. So why is there no more beta 0? This is in
H naught, beta naught is equal to 0.
Yes, that's the hypothesized what? Beta naught. which is equal to 0. So we have beta naught 0 over the standard error of what? Of beta 0. So here, this is the variance of beta naught. But now you have to take the square root of that number. Here we have to verify the answers if I did take the square root. Suppose this is the actual value, right, that we obtain, right? So if there's a mistake, you have to correct it. It should be the square root of the denominator. So if you compare this value and the one from the tables, we are saying since we should write, since the absolute value, sometimes we may get a t value which is negative. So that's why I'm saying emphasizing that in absolute value. So since t, the absolute value of t is less than 3.05, we fail to reject H0 and conclude that the regression model is not significant. Yeah, it wasn't supposed to have that conclusion. The conclusion is wrong, this one. We fail to reject H0 and conclude that the intercept or the intercept is statistically insignificant or it's not significant. Not that the regression model is not significant. No, this doesn't validate the regression model. So you have to state that the intercept is statistically insignificant or the intercept is not significant. So let's look at the next question.
Sir, may you please repeat on the conclusion?
Okay, I was saying the conclusion, this one is wrong. Okay. Right? You are not measuring the regression model. If you're testing for beta naught, you're checking for the what? For the intercept. So you're saying to conclude that the intercept is statistically insignificant. Or you can say that the intercept is not significant.
Oh, you know, sir. Hello?
Yes, I can hear you.
I would like to ask you, the mixture for Parigo, that the regression constant is not upon the regression model.
Okay, I see. Thanks. Yeah, it's just still correct. If you just say regression constant, but now the constants are different. It's better you say regression intercept is not significant. I'm sure it's correct. Thanks. I read it differently. So it's regression constant or regression intercept is not what? Significant. So it's actually correct. Now, let's look at the other question. It says, test for lack of fit using alpha is equal to 0.05. So what you need to do is to state the hypothesis again. To say, okay, what is your hypothesis? The simple linear regression model is correct. Usually when I'm modeling the linear regression model, you're modeling the mean of the response variable or the dependent variable. That's why they're putting expectation of what? Of y. So if it's correct, the expectation of y is equal to beta naught plus beta 1x. If it's not correct, the expectation of y is not equal to what? To this. So if you go to our table here, right, you see that we have got repeated replicates of what? Of the explanatory variables. So this is what we want for us. If we want to perform the lack of fit, we need replicates of what? Of the independent variables or explanatory variables. So you see that 4.5, it's repeated several times. It's repeated how many times? It's repeated year, right? 4.0 is repeated, 5.0 is repeated, right? 5.5 is not repeated, but at least we have got some variables, some values under the independent variables that are what? Replicates. So 4.5, it's replicated how many times? Thrice, which we have got 65, 105, 103. So the idea of doing this is for us to calculate SS what? Pure error. All right? It's for us to calculate what? SS what? Pure error. So these are replicates that you have for 4.5. These are replicates that you have for 4.0 under Y, right? Then for 5.0, for 5.5, 1.0, 6.0, 2.5. Then we get the mean of the replicated observations of Y. So that means you're going to say 62 plus 105 plus 103 divided by what? By 3. You get what? 90. Here you say 50 plus 52 divided by what? By 2, you get 61. Right? Then now you get the summation of the difference of the observation after you have squaring them. That means you're going to say 62 minus 90 squared plus 105 minus 90 squared plus 103 minus 90 squared. You get this. Next, you're going to say 50 minus 61 squared plus 72 minus 61 squared. You get this. So you do all the observations. Right? Then the degrees of freedom now it's m minus 1, right? How many distinct observations do you have in Y, right? That are in X, right? Remember, m is the distinct values that are not in X. So you've got how many of them? There are 3. So it's 3 minus what? 1, right? Which is 2. How many distinct values of X do you have with 4.0? That 2. So it's 2 minus 1. It's what? 1. You do the same for others. These are the degrees of freedom. So if you sum all this, the summation under this, the fourth column, you should get this value, which is 3,147. That's the value that you get from what? From that summation. Now m is equals to 7. Therefore, where they get this m, they to sum up the degrees of freedom for all these, right? Which are a minus 1 for the distinct values of what? Of X. They got 7, and then now these are the degrees of freedom that corresponds to pure error, which is n minus m. So what is our n? It's 14 minus 7, which is 7. So there are degrees of freedom that is relates to what? Pure error. So after getting the SS pure error, then now you're able to get SS loaf, because SS loaf we had said initially, we had said SS error is partitioned into the 2 components. So SSE is. So now we have obtained SS pure error. We initially had SSE on the ANOVA table. So what we need now is SS what? Loaf. So SS loaf is equal to SSE minus SS pure error. You get this one. And the corresponding degrees of freedom for what? For loaf, it's m minus what? 2. So what's m? 7. Right? And 7 minus 2 is 5. And for us to get MS pure error, SS pure error divided by its degrees of freedom, which is n minus what? M. You get this one? Then mean square loaf, you divide SS loaf divided by m minus 2, you get this one. Then F, you get MS loaf divided by MS pure error, you get 1.00. That's the one for lack of it. Then you construct the table that includes the ANOVA table for the regression and for the lack of fit. So based on this, now you have to come up with a conclusion. I'm sure, did we mention the conclusion? No, we didn't mention the conclusion. So we reject H naught if F is greater than what? F from the tables. This is the rejection criteria. So we reject H naught if F, so it's better you differentiate those F. This is F star. We reject H naught if F star is greater than F 0.05. So where are they getting these degrees of freedom? They're checking for the pure error and for what? For lack of fit. which is 5 and what? And 7. And then they go to the F tables under 0.05. This 5 is for the numerator, this 7 is for the denominator. You get 3.79. So now you're comparing this F, the F statistic that you obtain, which is 1.0, which is actually less than this one from the critical table. So which is, we fail to reject H0 and conclude that there is no sufficient evidence to say that the simple linear regression model is not correct. I'm sure you have to understand the statement, what it means. This was our conclusion. We failed to reject H0, right, based on what? On the rejection criteria. So when I fail to reject H0, what do we mean? We don't have sufficient evidence to say H1 is correct. So if you're going to fail to reject, if you're going to fail to reject this, can you meet, please? If you're going to fail to reject this, what it means is that we don't have a sufficient evidence to say the model is not correct. That's what this conclusion is saying. So it depends on how you conclude, but it should make sense when you're making conclusions. I'm sure if you did such conclusions and applied statistics, what one, that's where we deal with those conclusions. So we're saying there is no sufficient evidence to say that the simple linear regression model is not correct. So that's the end of chapter 3. They've gone beyond our time, which was 4 o'clock. So any questions, guys, you can chat. I'm giving you probably 3 minutes to ask the questions before we end the meeting. So you can chat on, send a chat, or you can ask verbally. Still okay. Any? Yes.
So please confirm that the lack of fit and pure error down of variation from error.
You want to understand what? Can you repeat your question?
No, I wanted to ask, is it that our lack of fit, back to the slide that you're on, lack of fit and pure error, something like that, are there a breakdown of error?
Yes, that's the breakdown of error. That's the sum of squares of error. Look at the one that I'm presenting now.
Mm-hmm. Right, sir. Thank you, sir.
Welcome. Any other questions, guys? So there's an assignment that I have posted on the WhatsApp group. That's our assignment is due next week, Monday. So yes, it's a filling assignment, which I only require only 1 page when you're sending the assignment, right? And if you go beyond the 1 page, I will not mark what is beyond that 1 page. So what you do your calculations aside, but in the exam, we are going to write all the calculations in the booklet or whatever, right? So if you are going to copy and paste, it's up to you. You know, it's easy for the system to catch up with you. I'm sure the results came out, you saw what you got. So the system is easy to catch you. Some pass, some don't pass. And you saw the group, what was happening on the WhatsApp group. The people that wanted to carry this course, and you would happen to carry it if you're not diligent with your work. All right, just go through your notes. If you don't understand the concept, you better ask me. All right, not ask me a day before the exam. So on Wednesday, we're going to start up on chapter 4, so that we manage to cover a lot of ground while we're still at home. By the time you come for the lectures face to face, it will be a matter of just revising some concept that you don't understand. So thanks, guys. Lynn.
Say,
Lynn,
say.
please share the video immediately
Okay.
for the benefit of others.
Okay, say. I'll do so.
Yeah. Thanks.
So,
Yes, Delight.
so are you saying for the assignment we shouldn't use those softwares ARA or SPSS to do the assignment? We should do it manually and then we fill in.
It'll be good for you to do the both, to learn how to do it manually. The manual way is the way that you're going to use in an exam, right?
Yes.
And using the SPSS or using the ARA, it will be to your advantage to understand how you got there, right? Suppose you're using more variables or big data, that you'll be able to use the softwares. But if you're going to rush to use SPSS or ARA in the exam, you might be disadvantaged.
Okay, thank you, sir.
You're welcome. So practice both. That's that's the encouragement that I can give you. So you can tell
Okay.
others what's best for you is to practice both. For life, for college to get a distinction.
It's okay, sir. Thank you.
You're welcome. Yeah, enjoy, guys. Bye.
Thank you, sir.
Thank you, sir.
Yes, say.